Just go to the About button. So just click on the intro. Yeah. So as Sanchit has mentioned, you know what it is all about, why we found the groups and all. So it's just a small intro, which generally we go through every meetup we do. Next slide, Sanchit. So so we are also a volunteer group. We are a bunch of people who are from the technical background, as well as professional teachers and entrepreneurs. And the primary interest is in Python as a programming language, but anything open source generally is most welcome in our group. Next slide. So we generally used to have fortnightly meetings in the world, but this has stopped due to last few months now. It is not happening regularly, but we plan to get that going, and we go and do workshops and education sessions. We have done 2 PyCon Indias and few local Python events also. Next slide, Sanchit. Meetups typically are in the same format as workshop, talks, networking, and coding sprints. Next slide, Sanjit. One of the big questions people ask us is why do we do it? This is basically a very great platform for networking, and we have found a lot of collaborators on lots of these projects. Sanjit, can you mute? I think your mic or whose mic is this? Somebody is.
I'll just check. I'll just check.
Yeah.
I think
So we have found lots of collaborators on projects. We do get consulting and mentoring from these user groups, let it be HydPy or Pythali, and like-minded people, and pro bono consulting also, in the sense of, like, a lot of people you come to me, you know, especially for mentorship, taking some guidance, because everyone does mistakes, you know. Instead of making those mistakes, they just ask me, and you know, so these kind of things happen in a group, you know, when we are in a group. Next slide, Sanjit.
Yep.
We generally ask this as a help from everyone, like, let it be an institution, organization, or place where we can host our meetups and increase the social media reach, and also give some talks. And most of the projects who want to code is on the GitHub link. There are a bunch of projects where people can have a look at it. Next slide. Again, the best way to stay in touch is, I think, now is Telegram, but we have blog Telegram because there was a lot of spam and there is not many people who can control it. So if you can get in touch with me or any of those admins, we have a bunch of them. We will be very happy to add you in, and people especially from NCR area, we will be able to add you, and even anyone from anywhere in India or around the world are welcome, most welcome. Yeah, next slide, please. So these are our achievements so far, and I think it speaks for itself. Next.
I think this is it.
This is it. Good. So yeah, let's get started, folks. Thank you, Sanchit,
Sure.
for organizing this, and hope we will have some great discussions around it. Bye bye.
Sure. Thanks, Satya. So a couple of thank yous to be made before we get started. So first of all, thanks to Pythali for coming forward and doing this collab event. And thanks to EPAM India as well for providing this GoToMeeting infra. This is very important because this is a difficult time for us. We can't organize the physical meetups. So such platforms are kind of very helpful. So I will get started and move towards. I think Uday, can you go on mute? I think you're. Yeah, I think it's better now. If you have a headphone, I think Uday, you should use a headphone because during the talk, I think there can be some voice coming in. But I'll quickly go and talk about the first talk.
Sanchit, is there any way we can see who all is there on the attendees? Is there any way we can see that, or you have blocked that?
I think I'll make you the organizer, then probably you will be able to see that. But any organizer, any person who is just joined as an attendee would not be able to see that.
Okay, because I would love to have those cross chats with between people, because that's what happens, when we are physically present. So
Sure.
yeah. Anyway, yeah.
I'll try and make
If
you
anyone
the
can
organizer
feel
so
free.
that you can actually see people and talk to answer questions as
Okay.
well.
Okay.
Yeah, just give me 1 second. This platform is also new to me, so I'm little unknowing of things. I have make you organizer, Satya, and anybody else from Pidali is on the call. I saw Vipul also. So please be with me, folks. I'll just do this and we'll get started. Anyways, Satya, you are the organizer as well, so probably you can make other people organizer if you want. About this talk, which is from Uday Kiran. So I'll just quickly introduce Uday. So here's Uday's intro as well. I think he has into industry for almost 1 year. He has a blog, an Instagram blog on machine learning, which has around 80K followers, and he's currently working as an ML intern in Synopsys as full time. So yeah, very small intro, but I think Uday can speak for himself. So let's welcome Uday on his talk about breaking the black box. I will make you presenter, Uday, so that you can
Okay, can you hear me right?
present yourself. Yeah, I can
Yes.
hear you. So I make you as a presenter now. You should be able to share your screen.
Okay,
Yes, I
can you
can
see
see.
my screen also? Okay.
Yeah, I can see your screen.
So yeah, so hello all. Like my name is Uday, and I'm working as a machine learning intern in Synopsys, like as I mentioned in that GitHub as well. And I'm working on NLP and time series in here in Synopsys. So like I learned a lot from the community, so I just want to give back to the community itself. So I started a machine learning page, and I'm teaching there machine learning. Like it's like a kind of a blog, not completely a medium blog or some blog. It is like a normal post, so you can check that. I'll just mention the link at the end, so you can check my Instagram page. So today I'm going to talk on the breaking the black box. You know, right? What is the black box in machine learning? So people usually say machine learning algorithms or deep learning algorithms are completely black box. That means we don't know what is happening inside that model. We don't know the structure exactly. We don't know the assumptions. Like, and we don't know what is happening inside. We just give the input, it gets the output. So it is not usually case. It helps in interpreting that black box helps in many domains. So I'll just explain that. So okay. So what is usually a black box? So according to the okay, just a second. Okay, according to Oxford, like it is a complex systems or devices or device whose internal workings are hidden. That's what I said in machine learning models, which are black box. We don't know the internal processing of that model, so which are hidden and are not ready or not readily understood. So this is what where I'm trying to breaking that black box and making that internal workings as understandable to the humans. So actually, what is machine learning? I know most of the people know what is exactly machine learning, but I just want to give some small introduction about the machine learning. So we have two kinds of things. Like one is traditional programming, and the other is machine learning. So how usually traditional programming works is Like you will be given the data and you will be given the instructions. So it will generate the output based on the instructions. Those instructions can be rules or some kind of rules itself. Like you'll be given the data rules and it will generate the output. So in machine learning, it is different. Like you'll be given data and you'll be giving the output. So it generates the rules. So that is what exactly happens in machine learning. So the usual definition of machine learning is it learns from the experiences. Like you have data which have some samples of of any real world samples. So it explains some experience about that domain. So based on that experiences, it learns to find some patterns from that data, which helps in predicting the output. So that is what usually machine learning is. I'm not going into deep about that because it takes some more time to explain that. So I'm just going with the high level explanation of that machine learning. So what is interpretable machine learning here? So interpretable in the sense you want to understand what is happening. As I said in that black box, you want to understand what is happening. So it is like up to what extent human can understand that decisions and choices taken by the model in making a prediction. So I said machine learning will make the find the patterns from the data. That is what the rules exactly. So you will be giving input based on that rules, based on that patterns, it will predict the output. So and you want to understand what are that rules, why why it predicted that output given the data. So that is what we usually say interpretable machine learning. So let's explain why interpretable machine learning is important. So usually in real world or industry, if you're doing any if you're solving any business problem, there will be some clients for you. So you will be asking some questions like uh, the usual question people will ask is why I need to trust your model. So it is very important for trust. This is very important to trust your model actually. So because I will say why it is important to trust your model. So one thing is fairness. Fairness is nothing but bias actually. So let me give some examples as well. So bias in artificial intelligence models is let's take an example like uh, let's take an example of a company like an MNC where people are working and there are both genders, female and male are working, and you want to give a hike for the people. So you're trying to solve that problem using a machine learning, and you want to predict who will be getting the high hikes, who will be getting the low hikes. So based on the previous history, the previous data, machine learning will predict the future outcomes. So based on your previous data, where you are given hikes to males and females, it will predict a feature like what can be the hike for a male or what can be the hike for a female. So when you usually look at the past data in many companies, usually men's will get the high hikes and females will be getting the low hikes. So based on that, it will predict the same thing in the future as well. So that is what we call biased, because it is completely biased to the males instead of females. So it is really problem, right? The females can work hard, they can earn more money, but because of that ML model, they're getting less hikes. So that is what one problem. And in last few years, there are many troubles with that bias. So people usually say that artificial general intelligence is not really threat now because it can take some more years to get into that, maybe 10, 15, 50 or 100 years maybe. So the real problem in machine learning or artificial intelligence right now is bias. So in previous years, like Amazon, like let's take an example of Amazon. What it did is it in US actually in US there are a few people like black people who are living in one area, and white people are living in other areas. But when the black people search for a product and they want to get it delivered to their locations, their zip code is invalid. That is because the previous history of black people, uh, that model learned is the black people are like thieves. They usually stole the products from the delivery boy. So what they did is they blocked that zip code, so people cannot get their products deliverable to that locations. So that is a serious problem which faced in the last years in Amazon actually. And when you take domains like health, uh, judiciary, or criminal or something, which is very important here in interpreting the models, interpreting the ML models, because we cannot blindly trust. Because if you take in a judiciary and you want to impose a criminal case on in some person, so based on that ML model, you cannot simply trust and give a life imprisonment, or 10 to 15 years of jail imprisonment. So when you look at when it is not from the machine learning model perspective, it can be around 5 to 6 years. But your machine learning model given 10 to 15 years based on the previous experiences. So this happened in US as well. Like when they implemented this ML model in judiciary, like whenever a black person gets into that judiciary, and they usually get a many years of imprisonment because of the previous history where black people are thieves, as I said in the previous example. This is what happened actually. But when the white people came into that judiciary, they usually get very low because of the previous history. So this is where the bias, like it is biased towards the white people instead of the black. It is not. It is biased towards the white people, where it is showing some fairness towards the white and a little bit of not fairness towards the black people. And when you take an example like your credit application or your loan application, so here also there is an example of same black people and white people. Like black usually don't get the loan approved because of the previous history, and white people are usually get an easy approval of their loans. So this is where interpreting the machine learning model can help you detecting that bias and solving that bias problems. So this is where debugging can help you, like debugging your machine learning models and knowing why it is biased towards the white people, why not towards the black people. So this is where it helps by interpreting, and it can also help in privacy, and there is a reliability and accountability where uh, like I said, you can see here why, how, and what. So I'll just go through this. So it can help in understanding reliability and accountability. So let's take these three kind of questions. Whenever you're building a model and you're showing it to your clients, so they usually ask three kind of questions. Like, what are the features really affecting your machine learning model, and how let's say you got few features which are important. Let's we have 14 features, and we have top 5 features are very important for this machine learning model. So now the question will be why this feature is really important. You got the top 5 features, and you have another question like why these top 5 features are really important. Why each feature is like what each feature is contributing to the final output. And the other question is like why I need to trust your model, because trusting your model uh, can say that okay, your model is working as expected, so we can trust your model and we can deploy it. So the accountability comes where uh, why a particular feature is important, why not the other features. And the regulations is like in previous year or 2 years back, the EU regulation came in. That is like, if you are using ML models in your business and it make a certain prediction. If let's take a credit loan application and your loan got rejected. So anyone can go and ask the bank why my loan is rejected, and they need to explain why the machine learning model predicted that output. That is the regulation. Like any human can go and ask why that algorithm predicted in a wrong way or in a right way. So it is really important now to interpret your ML models, and it can also help in feature engineering. Um, let's say we have 10 features, and we found that top 4 features which are very important. So you can do some feature engineering on that 4 features to generate a new feature or create a new feature by multiplying the first two or adding the first two or subtracting the first two, whatever. You'll be doing some feature engineering and you'll be creating a new features which can really help in improving the performance of your model. So this is why we say like interpretability is very important uh, to explain all these, like to trust your model, fairness, debugging, privacy, reliability, accountability, regulations, and feature engineering. So let's next see, and let's say, do you think that it is always necessary? Is it really necessary debugging every machine learning model? No. Actually, the answer is no. Because if we have any problems where you are solving, there is no significant impact on the customers. So you don't need to interpret your models. It can be example like if in Amazon you're buying a product and it will be showing some products. It will recommend some products for you. So if it is not recommending the right product, there is nothing happening there. There is no significant impact on customer, or there is no significant impact on the person who is buying that. So there is no need for interpreting these kind of models. It is just like a time waste or the computation power wastage. Or or take an example like, you are predicting to find where your friends will be going for a next vacation based on their Twitter feed or Facebook feed. You want to predict where they will be going for a next vacation. So if your model works good, then it is good. You can show, okay, you'll be going here, you'll be going here, and your friends will trust you. If your model doesn't work well, there is no significant impact on your friends. They can go to any place, they can visit any place. So in problems like where there will be no significant impact, you don't need to interpret your model. Or the next will be when the problem is well studied. Let's take an example of OCR applications, where you'll be recognizing the text from the images or PDFs or anything. You'll be recognizing the text and giving the text back as an output. So these problems, like OCR problems, are well studied from past 20 to 30 years. They are very, very well studied, and they know and they know everything like about that OCR. So it is really well studied, that problem. You don't need to interpret anything there. So these are the two places where you don't need to interpret anything. Uh, and yes, and let's get started with the interpretability techniques and everything. So there are we need to important to understand what type of a model it is and what kind of tools are there, or what is the scope of your interpretability. So these three helps you in understanding and everything of your model. So the first one is intrinsic or post hoc. So let's take an intrinsic. What is intrinsic is the machine learning models which are interpretable in nature or by nature. Let's take an example of linear regression or logistic regression or decision trees, which are interpretable by nature. You don't need to use extra tools to interpret your model. You can use one. There is no need to use the extra tools for interpreting your model. Because if you take in a linear regression, if you want to find what are the important features, so you can simply use the coefficients or weights, we can say, to just give what are the important features, whether, like you can say, if the weights are high, you can say that feature is very important. If the weights are low, you can say that feature is not very important. So these are the intrinsic models which are by nature interpretable. And when you come to post hoc, these models are not by nature interpretable. So you will be building the model and you'll be generating the complete model, and you'll taking that model outside, and you will be applying some tools or some other algorithms on top of the model to find the to give the interpretability. So the model here in the sense already is a trained model. So you'll be having a trained model, and this is another layer on that trained model where it tries to explain the interpretability of the underlying trained model. So when we come to model specific or a model agnostic, so model specific tools, these are the algorithms which helps you in interpreting your results. So these model specific are specific to the algorithms, specific to the machine learning models. So if you take an example like linear regression or neural networks, so you will be having weights in them. So you will be using weight specific algorithms to interpret your results. When you come to decision trees, you cannot use these weight specific models to interpret the decision trees because we don't have weights here. In decision trees, we have splits, or we can say Gini information gain or entropy values. So we will be using decision tree specific models to interpret the decision trees, or random forest where we're using the decision tree itself. So we cannot use these models to predict the weight specific models. So these are completely model specific. So we cannot use one specific model to other specific models. So when you come to model agnostic, you can, these are the tools like you can apply to any algorithm. It can be intrinsic or it can be post hoc. You can just simply apply these tools or models to those underlying models. It can give the interpretability of that underlying model. But when you take in a model specific, you need to have the complete, you need to have a complete package. You need to know, you need to have the weights, you need to have the model structure, you need to have the uh, model assumptions, and you need to have the data as well. So when you come to model agnostic, it doesn't care about the model. It doesn't want the what is the structure of the model. It doesn't care about that. If there are any assumptions of that algorithm, it doesn't care about that. It only takes input, it only takes the output, what is the predicted value, and what is the relationship between the input and output. So because of this, we can apply model agnostic on any algorithm because we don't care about the internal structure. So when we come to this local or global, this is scope up to where you're interpreting. So if you take a local, that means your interpretation is completely talking about, or that method explains about single prediction. Let's say you have 100 samples in your test data. So you want to know the first sample. The first sample is predicting something, and you want to know why this first sample is predicting that. You don't care about the complete data. You're just predicting only on one sample. When you come to global, it is like you want to understand the interpretability based on the complete data set. It can be 100, I said 100 samples, so you'll be using all 100 samples and you're predicting some output, and you want to understand how this model is generating that output based on the global structure, not on the local. So I'll be just explaining the scope in more detail, in detail. So when you take a global scope of your algorithms and you want to predict prediction based on the complete data set, so you can answer these two questions, like how does the model make predictions, and how do parts of your model affect the predictions? Because I said global will be taking everything. It will take model structure, weights, data, a complete data set and everything. So if you just see your data set, if it is having more than three features, it is really difficult to visualize them, because we can only visualize 2 dimensions or 3 dimension data, not more than that. So if you have more data, then one thing you can do is in global is you can make this complete data into modules. One module can be weights, one module can be assumptions, one module can be input, one module can be output, and you will be solving each module, and you'll be combining all these modules results, and you'll be giving the complete result. So so that is what the global, you will be having the complete package, and you'll be predicting, you'll be interpreting your complete everything. And when you look at the local, you can answer these questions, like why did the model make certain prediction for single instant? As I said, one instance which will be predicting something. So you want to understand why it is predicting that. So, and the next one is a group of instances, not the complete data set. You want to understand why these group of instances is predicting the output. So what this local will do is, it doesn't care about the model and its structure. It completely treats your ML model as a black box. It just have input and output, and it finds the relationship there. So what it do is, like, it will take that single instance and it will consider its neighborhood points. So if you can see the KNN algorithm, where there will be one point and you'll be just finding the distance with the other points, and you'll be taking a top k least distances. So it works in the same way, like you'll be taking one instance and you'll be considering the complete neighborhood instances to understand why that single instant is making that prediction. It gives the more accurate results than global. I'll show why it is. So let's get into the techniques what we use in interpreting the ML models. So the first one, the first thing is like traditional techniques which are used in years or previous days or previous years. The two things which they usually use, like exploratory data analysis and performance evaluation metrics. So when you consider these exploratory data analysis, there are many techniques in exploratory analysis which can give which can like it helps you to identifying the key features and meaningful representations from the data, which can help you understand the influence of that features, and human can understand that. In a way, human can understand that. So there are many techniques in exploratory data analysis, like dimensionality reduction, or you can use clustering algorithms to interpret your results. So when you come to dimensionality reductions, we have principal component analysis, or self-organizing maps, latent semantic indexing, or t-SNE, which we call t-distributed stochastic neighbor embedding. Or we can use deep learning algorithms like autoencoders or variational autoencoders, which are all these are like dimensionality reduction, which reduces your 100 dimensions or 150 dimensions into 2 to 3 dimensions, where you can easily visualize them. So when you visualize these, when you visualize like in 2 dimension, 3 dimension, you can understand what the structure is and why it is predicting that, not in a complete detailed manner, but you can usually understand by looking at that visualizations. So, and you can also use clustering algorithms like hierarchical clustering or dbScan to understand why it is making such kind of predictions. And when you come to the performance evaluation metrics, so these also can help you in understanding a little bit of interpretability about your models. Because when you take this ROC curve or precision or recall, it can tell you how your model is performing, like how it is giving the true positive rate or false positive rate, or true negative rate or false positive, false negative rate. So based on this, you can improve the performance of your algorithm. So based on the evaluation metrics itself, you will be doing some hyperparameter tuning or cross validation or any other techniques which improves your algorithm. So these helps in giving a little bit of interpretation to your models. When we come into regression, we have root mean square, R square, or mean absolute error. When we come to clustering, we have absolute coefficient, homogeneity, completeness, or any evaluation metrics. So it is really important to understand the interpretability versus flexibility, this graph, because when you see the easily interpretable models, like I said, uh, interpretable by nature. When you consider the algorithms like uh, linear regression, logistic regression, or decision trees, these are easily interpretable by nature. But when you use these algorithms, their flexibility is very low. That means the performance is very low when you consider that, because these are fixed. These are a fixed function and a fixed assumptions. So they don't go beyond that. So if you take a linear regression, the assumption is the data should be linear. But in real world, you don't get that every time. Your data can be non-linear or any other shapes. So linear regression doesn't give the complete flexibility of getting high performance. A decision trees in the same way. So when you consider the high flexibility models, your interpretability is very low. Like I said, you have a low flexibility like linear regression or decision trees. The interpretability is very high, because in linear regression or logistic regression, you'll be using weights to define what features are important, why that feature is important. So interpretability is high here. Decision trees as well, splits or gain, it will take all this consideration, gives the important features. But when you come to high flexibility models like random forest or gradient boosting trees, or deep learning, we can say neural networks or SVM, these are like high flexible models. These doesn't consider, like, they have assumptions, but they are flexible to any kind of data. It can be linear or it can be non-linear. So when you consider these algorithms, the interpretability is very low here. You cannot go and interpret, because if you take random forest, you'll have thousands of trees or 10,000 of trees, who knows. So it is really difficult there to interpret your results based on that 1,000 or 10,000 trees. So when you get into gradient boosting, so it is like sequential trees. So it is really difficult to understand the previous tree, what it is doing, or the next tree what it will be doing. So the interpretability is very low here. The neural networks are same. It has weights, but it is completely like non-linear structure, because you will be using non-linear activation function, and you will be making that neural networks very complex if you have more number of nodes or more number of layers. So the interpretability is very low. So we'll be using few techniques where we don't lose the flexibility, and we'll be having a high interpretability. So today I'm going to just show the interpretability of random forest and XGBoost. I'm not going to deep learning today. Maybe in next meetup. So I'll be explaining how we can use a few tools to get the interpretability. So what are the limitations of these traditional techniques? So when you just see the life cycle of a data, like data science life cycle, where you'll be where will be you here you can see where you will be collecting the data, testing it, model refinement, model exploration, or deploying it, monitoring and maintaining. But after few days or after few weeks, your model performance will be degrading because you'll be getting data from a different distribution. Maybe you can get the data from different distribution, and your model performance is completely getting low here. So again, you need to train your model on the new data, and you'll be deploying it again and again. Your model with again your model performance will be degrading after a few weeks. So instead of training, deploying, again training and deploying, why don't you understand uh, why it is predicting in that way? So if you can interpret your results, so the chances of performance degrade will be very less. So if you use traditional techniques like visualization or something, which cannot help you in improving the performance of your model after a few weeks. So it will definitely, your model performance will be degraded. So that is where the one limitation of your traditional techniques. And the other one, you can look here, the stop sign board. So previously in last few months, a few people from Tesla, like they use a Tesla car and they want to check whether it is working correctly or not. So what they did is they just taken the stop sign board. It is somewhere around 2 kilometers away. So they started driving their car, and when it looks at that stop board, the car stopped. And what they did is like they add a few stickers on top of that, or they colored one, and they also use a few stickers there. And they again started to drive 2 kilometers away from that signboard. But when it looks at stop signboard, the car didn't stop. Like it's like it's continuously moving. So this is what we usually call as adversarial attacks. So what it is, like you're fooling your models, because just pasting the stickers, your model is failing. So when you just check about these deep learning models or self-driving car models, it is really important to understand why the car didn't stop, because it's like a human in that. It's a life. So you want to save that life. So if you, instead of stopping there and running with your car on any human or any bicyclist beside that, a human life is lost actually. So that's what interpreting is very important here, to know why it detected that, or why the car is didn't stop. And you can see these examples, which is recently came out from a university in Belgium, I guess. So what they did is they just holded some painting, uh, painting on a paper, like it is a color painting, and they just hold that. So you can see the machine learning model detected the other person as a person, and the person who is holding that printed paper, it is not detecting as a person. So this is where you can fool your deep learning systems, and you can check why it is failing and everything. Where your traditional techniques will not work in understanding why it is doing this. So you need more advanced techniques, where you need to have more advanced techniques to understand why this is happening. So we'll be going with the next, like what are the interpretation techniques. So first thing you can use is interpretable models itself. Like I said, easily interpretable models by nature, which are easily interpretable. So you need to understand every model in three things: whether it is a linear, or whether it is a what we say monotonic, or is increasing, what we usually say that, or you can see whether there is an interaction between the like automatic interaction is there or not. So when you just see the linear models, which are linear by nature, their underlying assumptions itself is linear, and obviously monotonic. If the feature is increasing, the output may increasing. If the feature is increasing, the output may decrease. There is some monotonic structure. There can be some monotonic, increasing or decreasing way, and there will be and there is no automatic feature engineering in linear models. And the task is like regression. Linear models are regression. So when you take a logistic regression, it is linear, but you can add a polynomial term in that, and you can make the logistic regression as a non-linear, and which is also monotone, and there is no feature interaction there, because but you can add a external feature interactions there, and it is a classification task. And decision trees are same. They are not linear, and there is some monotone, and there is some internal feature engineering will happen in decision trees, and you can use it for classification or regression. A rule fit, same neighbors or a k nearest neighbors. You can just see this one, and you can understand what is happening, why we can use these algorithms, or and why not we don't use these algorithms. Okay, let's see the next important interpretation technique called permutation feature importance. So this technique is like, just a second.
And
Okay.
Uday, just a quick time check. We have only 15 minutes left for your talk.
Yes, I'll just complete that.
Sure.
So this is what I'm saying. Where if you're checking these interpretation techniques, these models are very too simplistic, and we have a better ways to build and interpret more complex models. So this is where we just come into permutation feature importance. So the steps of this algorithm is like, you'll be getting a trained model, and it is model agnostic. We don't like I said, it doesn't care about the internal structure and anything about the model. So it will be having only input and output. So you'll be getting the trained model, and what you will be doing is you'll be shuffling the values in every column. So you will be taking one column, and you'll be shuffling the values in that column, and you'll be calculating the loss, and you'll be comparing that loss with the original loss, and you'll be doing this shuffling in every feature, and you'll be computing the value for every permutation feature, and you can check which feature is very important. So I'll be just showing the code as well for you people. So first we'll be talking about the feature importance, and the data set I'm using here is heart disease data set. Whether because with these features you can predict whether the person is having a heart disease or not. So I will just these are um, the libraries we are using. So I will just importing it, and I already have that data set, so I'll be just loading it, and you can check the data head. So you can see all these features and the values in that, and the target is like 0 or 1. 0 in the sense the person does not have no heart disease, and 1 is like heart disease. So I'll just splitting the data into test and train. So here I'm using the ELF library for permuting the feature importance. So I'm using random forest. I'm not talking about anything about the model, because we just want to understand what type of features will be important. So I'm just showing that. So we'll be using the permutation importance here, and it will be showing like what are the important features in making that decisions of that model. So like you can see the CA, CP features where they have the high values. So permutation important, the permutation feature important, what it says with these weights is the first value will be if you shuffle this row, like you can lose the 7% from the 7% accuracy from the original loss. And this is like variance because you will be averaging, you'll be doing multiple shufflings and you'll be finding the confidence intervals. You can say 7 plus another 5. So it can be around, the confidence interval will be 2 to 13%. If we shuffle this, you will be losing the accuracy from 2 to 13%. Like it can be from CP can be 1% to 11%. So this is where you can understand what are the important features here. And when we are using XGBoost, uh, you'll be getting around the same results like CP, CA, and the gender of that person, or cholesterol or anything. So when you want to understand why, like it is like local, you want to understand why this prediction. So I just taken the 0th index, the first prediction. So if the actual label is 1 and the predicted label is 1, so you can understand what are the features played a major role here. You can see the CA, Thal and Thal, which played a major role in predicting that document as 1. Uh, so you can check with anything like let me show with another document like 0, which is predicting there is no heart disease. So you can see these three played a major role in predicting there is no heart disease. But when you check with this, it can say these are the three major things which played a major role in uh, saying that there is a heart disease. So we can use the other library called Skater, like which can also give the same thing. Like what are the important features here? By using, I'm just using random for this. It just given CP, Cthal here. So when I'm using XGBoost, it can give around age or CP. These are the important features in the algorithm. And the next technique will be partial dependency plots. So I'll be just going the pros. It is very simple and intuitive. It is easy to compare, easy to compute, and does not require retraining because you're just reshuffling and finding the predictions. You're not retaining your algorithm. And the cons can be like you don't know which data set to use. There is no clear understanding of whether to use a test or trained data set. And the other disadvantage is like different shuffles make you different results. So what one thing we can do some hack here is doing multiple shuffles and taking the average, like I said, the confidence intervals. And it is greatly influenced with the correlated features, and it definitely requires the labeled data. Like these are the disadvantages. And when we come to partial dependency plots, it is also model agnostic. We'll be getting the train model, and what we will be doing is repeatedly altering the value for one variable. So I said the first question will be what are the important features in predicting your model. The second question will be why that feature is very important. So this partial dependency plot will give why that feature is very important. Okay. So what it will do is it will take a feature and it will keep the remaining features as constant, and this feature will be changing from a low value to high value, and it will predict what is the output you are getting for every value, and it will repeat with every column and you'll be getting that. So let me show for CP value. So for the CP feature, I'm just generating the partial dependency plot. So you can see when the CP value is 0, there is a low probability of predicting it as a heart disease. And when the CP value is increasing, the probability is increasing of predicting the heart disease. So these partial dependency plots help you in finding the relationship also, whether it is increasing or monotonic or any complex structure. So you can use these to define for every feature. Let's say CA, if you have a 0, it is a high probability, it is a heart disease. When it is decreasing, it can say there is no heart disease. So you can take old peaks or you can use any feature. We don't have time to, I'm just going through just when we take an age and you can see the people between 55 and 60 or 65, there will be low probability of having heart disease, but above 65 there is a high probability again. So you can do that, and it can also, like partial dependency plots, it can also give the combination of two features. So you can plot CP and CA, what is the relationship between them, and how this relationship is affecting the complete other the output value. So you can also check here, based on these low values, the blue score is like high, the green score will be low. So you can see this predicted one is like probability. So having 0 and 0, it is a high probability, because CP value 0, CA value 0, and CP value 0. CP value 0 is having the low probability of having heart disease. CP value of 0 having a high probability of heart disease. So you can get this from partial dependency. I'm doing the same for XGBoost. I'm not going through that. You can go through that. I'll share all these things. And the other algorithm which we cover is, so the procedure in T2 and it can available in anything. Like the main assumption of this partial dependency plot is feature independence. It should be feature independence. When we have a correlated features, we can use this accumulated local effects plot instead of partial dependency plots. And you can see the maximum number of features we can visualize only 2. So that is the biggest disadvantage here. We cannot visualize 3 or 4, the combination of those. So global surrogate models is like, it is another method. It is also like model agnostic. What we'll be doing is, we'll be getting the data. We'll be training a black box model, and we'll be training another interpretable model, where this interpretable model will assume, it will assume that it is very near to the black box model. So here you can see, measure how well the surrogate model replicates the predictions of the black box model, and we can interpret the surrogate model. So the steps here is, you'll be getting the data, you'll be training a black box model, and you'll be getting predictions. So, and you'll be training interpretable model, which will be using this data and the predictions of the black box model instead of the original predictions. So you can give the example, like it can give the approximation of that black box model. So when you have a black box model which is very complex and you can't interpret that, so you can use some external layer of interpretable model which can approximate the predictions of the black box model. So it can help in that way. Like it is very flexible and intuitive and straightforward. You can understand it. And what the disadvantage is, it gives the conclusions about the model, not about the data. So it is the biggest disadvantage of the global surrogate model. Sorry, it is not pros, it is cons. Some mistake. And it also depends on the surrogate model used. Like if you are using a very high flexible model, like very high interpretable models, you get high results. When you are using low interpret models, approximation algorithm, you'll be getting very low results. So line is one kind of using the surrogate methods. So what line is, when you want to understand each prediction, when you have a prediction, it is local. You want to understand the local scope of every prediction. So it will be doing the same thing. But it is local. It will be using the local surrogate methods. So what you will be doing is, you'll be selecting few instances, and few instances you want to understand the interpretability of that. And the next step, what it will do is, like it will take the variations of these instances. So it will generate another data set which has the variations of your instances. And these instances are weighted based on the proximity, how close there are, how close these another proximity it will do. And we will be training a interpretable model on these weighted data set, and you'll be interpreting that. So I'll just go through this one. So I'm using XGBoost here. So I want to interpret the document number 11. So this function, like this will generate the artificial data set, as I said. So so I want to understand the the interpretability of the domain number 11. So the actual label is 1, the predicted label is 1. So you can understand it's predicted 1 with a 99% of 99%, like 0.99 probability. And you can see how these feature values, so CA value is 0, thal value is 2, CP value is 1, and slope is 1. So these are the original values. And you can see if the CP value is less than or equal to 0.0, there is a high, like it plays a major role here. 0.4 probability, it plays a major role in predicting the actual label. So the same thing, 0.2%, 0.2 probability, 0. And the CP value plays a 0.2, and slope 0.13, and like that. So you can easily understand this one. So when we take in a document number 3, which is predicting the actual label as 0 and predicted label as 0. So you can see these plays, the CA plays a 0.4 probability in predicting the output, and 0.27 as a CP, thal as 0.3, and charter as 0.12. And these are the other things which are dragging, making the probability towards 1. But there is high probability of these features to predict the actual label. These and the pros are like it's a very flexible. You can use any algorithm on that data set, and it works with any kind of data. It works with tablet data, it works with text, it works with images as well. And I said guaranteed high precision because it works only with the local. So no correct definition of the neighborhood. Like it is in still development phase. So there is no correct definitions of why we can say this neighborhood is very important when we compare to the local. And if you repeat the sampling process, you'll be getting the different results. And yeah, that is also a disadvantage here. And I'm not going through this stuff because we don't have time. So I can say the very good, like I can say the very good reference. Like this is the best book. Like you can say this is the Bible, this is the Quran, this is the Bhagavad Gita of interpretable machine learning. Like the most of my material is taken from this book itself. So like it is really very good, which is written by Christoph. Like you can learn this book if you want to understand the complete mathematical side of those algorithms which I explained. You can get everything from this book. And you can contact me anywhere, like on LinkedIn, GitHub, or you can see my community or my personal Instagram community Instagram. So you can contact me anywhere. And yes, and thank you so much for Hyderabad Python user group and the Delhi Python user group for giving me this opportunity. They are really doing a great job in making others learn by like someone is sharing the knowledge and making others learn. So this is very really good initiative. So I'm really thankful for that. They're giving opportunity to share my knowledge. And yes, I'm done right now. And thank you so much for everyone listening to this talk.
Yeah, thanks,
Yes.
Uday. Thanks a lot. If anybody has questions, please raise your hand or send your questions via questions options. I'll be
Yes,
able to take them up.
I can answering that. Yes, I can answer
Yeah,
them. Or else you can just send your questions to I said Instagram or LinkedIn, so I can answer your questions. Or Telegram
I
of
think
Hyderabad user group.
okay. I think somebody named Leela has a question, so I will just try and unmute. I don't think I can unmute her. Okay. Probably send your questions through the questions options. Okay. Uh, Avinash is asking, can you tell the difference between lime and chap?
Yes. When you take the lime, as I said, it will be completely taking we consider the probabilities mostly. Like I said, how much it is probable, how it is affecting the feature by taking the variations of that data set. So when you
Okay.
consider the sharp, what it will do is it is like a game. It completely came from the game theory. So it will be assigning some payout for them. based on their contributions. So I can explain that, but we don't have certain time. Maybe you can just DM me so I can explain more clear for you.
Okay. Dhruv is asking, can you give the example of statistics in machine learning?
Sorry, I didn't get that question actually.
Dhruv is asking, can you give an example of statistics in machine learning?
What is actually, I don't understand the question.
Statistics.
So I think you're asking the exploratory data analysis, the statistics,
Yeah.
the statistical way
Yeah.
of understanding the data set.
Probably he's trying to understand that where exactly in machine learning you would be using statistics and how it will be helpful.
Yes. So mostly we use statistics in exploratory data analysis itself, or when we are trying to understand. We have statistical modeling methods where we'll be using statistics there to understand whether the weights, whether the coefficients are correct or not, or we'll be using hypothesis testing to understand whether the weights we got from the model is giving the right answers or not. And we mostly use the statistics in exploratory data analysis. We will be using confidence intervals, we'll be plotting the distribution of the graphs to understand how the data is distributed, or histograms, or anything you need to understand how the data is distributed and what are the frequencies it is having when we consider the categorical data.
Okay. I think that answers his question. The next one is from Aditya. He's asking how to decide which interpretable technique to use in different scenarios.
uh, if you ask me, like I said, whether you want to understand the global interpretation, like the complete interpretation of your model, so you will be using the global scope algorithms like partial dependency plots or permutation feature importance. And if you want to understand the local, if you want to understand if you want to understand the interpretation of the instance, why it is predicting in that way. As I shown you, like the document, some document is interpreting as 1, some document is interpreting 0. So I want to understand why it is interpreting in that way. So for that purpose, we'll be using the local model agnostic techniques like line or sharp.
Okay.
Yes.
The next question is from Leela. She's asking, can you tell about, can OpenCV be used to train objects for a robot, maybe in future?
Maybe I don't know about this. Maybe we can do that.
Okay. Okay. Uday, would you mind turning on your video so that it could be a little more interactive while the question answer session?
Yes, actually, I'm not in a good condition. Like it's working from home.
Sure, no worries. So, okay, Sagnik is asking what methods can be used to determine if a model is biased?
Uh, like there is no certain techniques to find the bias, uh, because because the bias is not completely because of the artificial intelligence models. The bias is because of the humans who are getting the data, who are training the algorithm. So by deploying it only, you can understand whether the model is biased or not. So to get rid of that bias, you can have a team of a complete, having a demographic team from different places or different race or different genders or different age group to get the data as correctly, and you can use that data to get rid of the bias. Yes.
Okay. I think Dhruv is trying to answer that question. He's mentioned that with the help of bias variance trade-off, you can do that. I
Bias
guess so.
variance trade-off is it's a different thing. The bias which I am talking is a different thing. Uh,
Okay,
yeah.
understood. Uh, Anukriti is asking how to evaluate model performance after implementation.
As I said, you can use the performance metrics to evaluate the performance of a model based on the type of output you're generating. You can use different performance metrics. As I said, if you're using regression, you'll be using RMSE, R squared, or another thing. For classification, you'll be using accuracy, confusion matrix, precision recall, or reference score. So it will be depend on the output of your data.
Okay, sure. Okay, Aditya has one more question again. He's asking if you use two different techniques, like for example, lime and chap, it gives two different explanations. How can we decide which explanation is better, and is there a metric to do so?
Yes, when we there is no exact metric like this interpretable machine learning. There is a lot of research going on, so there is no exact performance metrics to evaluate the interpretation. Maybe it can be like application level or human level, where after you are deploying it, someone third person will be monitoring that, or a human, like when we are generating the results, the human can see and understand, okay, this model is interpreting good and this model is working good. So at present there is no perfect evaluation metric for comparing two interpretable models. So it completely depends on the human uh, by looking at the results itself.
Sure. Any more questions, guys? Please. Yeah. Sagnik is asking, can you share some info on the model robustness against adversarial attacks? Basically, adversarial attacks are used to fool the model by hackers. Any tools available? I can repeat the question if you want.
No, I got the question, but yes, as I said, the adversarial attacks will used mostly by the hackers itself. Like I said, in Tesla, you can just um, paint the signboards or paste the stickers on the signboards where you'll be fooling your deep learning models. But there is no technique right now uh, to fix this one automatically. So based on the, I said, based on interpretation itself, you'll be understanding why it is detecting, why it is not detecting it as a signboard. So based on that, you can improve your model by getting some data or doing some feature engineering there. So basically, you'll be understanding the latent feature interactions by doing this. So you can understand why it is predicting in that way. So at present, there is no technique, automatic technique.
Okay. Just let me get the questions again. Just 1 second, folks. I think I lost my questions window. Yeah, here it is. Okay. I think we are almost out of time for this talk. So probably these questions can be answered offline. Can you do that today?
Yes, where I can find that in chat window.
In questions options, since you are an organizer of this thing, you should be able to see questions and you can answer them. Okay. So it should be good. I think you can answer them offline and then probably we can proceed with the next talk, which is from Madhur. So are you all okay for that? I think, can I get a thumbs up on chat or on questions if it is okay? Cool. All right. So the next talk is from Madhur Asija. I'll just open his GitHub issue.
Hey, Sanjay, let people know if they need some break or something, or they can just take a break right now, or what?
Yeah, I think we also need some time to actually connect Mother because he is not on GoToMeeting, so we would need some time for him to be connected. So I think we can take a quick 2-3 minutes break or 5 minutes break to come
Yeah,
back, and then in meanwhile I think we can start.
sure. That's a good idea.
Okay, so let's start at 11:30 again. It's
Sure.
11:25 right now. Yep. Thanks everyone.
Thanks.
Um, Hello everyone. So looks like Madhur is facing some technical difficulties to connect to his Office VPN. So I think he'll take a little more time. So please bear with us. So folks, there is an important update. Looks like Madhur is not going to be available for this talk. He is facing some technical difficulties to connect to his Office VPN, and all of his code and slides are on his Office VPN. So he will not be able to do his talk today. But to cover you all, we have Anuvrat from PyDelhi. He is going to talk about an interesting topic. I'll just share. So this is not related to ML, but I think it's a very interesting topic. How do you implement the Zen of Python in the real world? I'll just open that. And as soon as Anurag joins the call, we will actually make him the presenter. So it is one of the proposal for PyCon in India 2019. He's going to talk about the same talk here. Let Anurag join on the call. Anuvrat, you shall be able to speak now. I'm just going to unmute you. Anuvrat, are you there? Okay. So you are on your mobile right now, right? Okay. But I think from your mobile, I make you presenter. So I'm not sure you can share that. Probably you can join that Hangout, and I'll share my screen with people. Okay, just a second then. One second. Okay. I think you may have to mute the voice there. My voice coming to you. Okay. Okay. Yeah. So can someone confirm that they're able to see my screen and ultimately Anuvrat's screen?
I see your screen and his screen also.
Awesome. That's great. So Satya would like to introduce Anuvrat.
Yeah, sure, I'll do that. Anuvrat runs a company by the name Essentia Softserve, and he has been an old-time Python user from the PyDeli user group, and before that, he's a Bachelor of Engineering from Computer Science from Amity College, and he's been very active in the community right from PyCon days in the PyCon community, and he's been helping out with lots of events as well as technical things. Over to you, Anuvrat. And if I missed on anything in the introduction, you can always talk about yourself also. Anuvrat? Hello, Anuvrat. Can I hear? I cannot hear you. Sanchit, are you muted?
Oh, I can speak. I think I'm just looking at Anuvrat's screen. Anuvrat, I think he's muted.
Yeah, tell him that.
Anuvrat, can you unmute yourself and then check if the voice is working? Anuvrat? No. I think you can speak now. I can hear your voice now. Okay. For me, it says that it is self-muted.
Yeah, it's better. I should be audible now.
Yes, you are audible now. Go ahead.
Perfect. Good. Hello, folks. It's still good morning. So, good morning. I'm Anuvrat, and I'm going to be discussing how Zen of Python applies to us as developers, as members of the technical crowd in our general life, um, in our day-to-day activity. So, this little piece of sort of technical poetry was written by Tim Peters. All of you can just go to the Python prompt and write import this, and you'll see this text pop up. Well, let's and some people actually try to follow this down to the dot in their the day-to-day activities. Let's dive into that. Let's just read through it once before we get into examples of every line. It says, beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, flat is better than nested, sparse is better than dense, readability counts, special cases aren't special enough to break the rules, although practicality beats purity. Errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. Although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. Okay, that's the Zen of Python. What we'll do is we'll go through each line and try to see what we can infer from it, what it tries to teach. So, so as I said, some of these will apply more to the approach we take while solving problems than the actual code, the process of trying to solve those problems. These are guiding principles. Let's dive. So it says beautiful is better than ugly. One might ask what does beautiful mean? Well, more often than not, when it comes to our day-to-day activities, it would apply to the code that we are writing, the environment we're living in, the structure that we are creating around ourselves. So if it's beautiful, if it's pleasing to the eye, we are more productive. There is little to software engineering than arranging stuff and keeping them organized. So most of us have started working from home, and more often than not, you will experience that if your desk is cluttered, or if you are trying to work from the kitchen or the bathroom, you won't be productive, or the bedroom, for instance. Sitting on the bed and working is not a good idea. And having a clean and clear desk makes us productive. Same thing applies to our code base as well. If it's cluttered, if things are just jumbled up, one module into another, things are tightly coupled, it's bound to make our life difficult. And by life I mean debugging things. When you're trying to follow the logic from one end to the other and you have to jump through 50 files to figure out what the code is doing, well, one will get frustrated and more often than not give up or just switch to some other task. So, well, beautiful is better, and we should try to keep it such. Explicit is better than implicit. If things are happening magically, we won't be able to follow things. And again, since we spend more time debugging and reading code, while this may sound counterintuitive to beginners, it's what we do. If you're writing code only once, then it's highly likely that your code is not being used by anyone. Because once you start writing code that is getting used by other people, you'll get feedback, you'll get more feature requests, you'll in some or the other form you will have to go back to that code and modify it, update it, debug it, and live with it for a decent period of time. For example, I joke with a few of my friends who have just become parents that, hey, you started the biggest project of your life. As a corollary, the projects that we create have their own lives. Actually, we give birth to something, and it becomes our responsibility to keep it alive and keep it functional, make it grow. And if it's not possible, if browsing through it becomes difficult, now wouldn't be a good place to be in. So things should be explicit. Things should, if you look at it, it should mean what it says it does. This means naming things properly. This also means that if we go dive deeper into the code, it would say, hey, don't have catch-all imports. Don't say import from XYZ module import star. If you have like 20 such imports in your code base, no one will be, and you happen to use some function, nobody will be able to figure out where that function came from. You would have to search the entire code base to find where that function came from. Same thing applies to the functions and its arguments. If you're using just positional arguments, if there is only one positional argument to a function, you might just as well pass it. But if there are 15 arguments and all of them are being passed without calling them what they are, well, debugging and following through and reading will become immensely more difficult. Moving on. Simple is better than complex. Complex is better than complicated. So this one tries to apply and appeal to how we solve problems. If there is a simple problem, the principle says solve it with a simple solution. Do not try to craft a complex solution for a simple problem. This could, in fact, if I have to draw a corollary, it could mean that if you're trying to write a simple web application, and it does not need a humongous infrastructure, we shouldn't try to do that. If it's just 2 or 3 API routes, just use Flask and get done with it. If it doesn't need extensive search capacity, don't just for the sake of satisfaction or just for the sake of our kida, if I may abuse that term, insert Elasticsearch into it, and as such, try to use the simplest tools, keep as few moving pieces into this system as possible, because simple would be easy to maintain. Again, the second part of the statement says complex is better than complicated. What that refers to is that a complex solution would require complex solution, a complex problem statement. If we try to create a simple solution for a complex problem, that would be bad as well. But at the same time, even if the problem is complex, we shouldn't try to overcomplicate things. One way we do that is by trying to think of all the edge cases before we start writing the code. And or rather, thinking about the edge cases is good, but if we try to solve all of those edge cases even before the product goes live, then we might as well be creating writing the tool or developing for 10 years before things are done, and that such a product may never go live. It might never see the light of day or end users. Similarly, if we try to prematurely optimize, there is that saying which says premature optimization is the root of all evil. I forget who said that. If we try to create an architecture which can handle immense amount of scale even before that particular product has one user, it's not a good idea to do such a thing. So yeah, simple is better than complex. We should try to keep things as simple as possible, but if they require a complex solution, we shouldn't shy away from thinking up of a complex solution. Going to the next topic. Flat is better than nested, sparse is better than dense. In Python world, what this means is that we shouldn't make nested modules just for the heck of it. Try to keep things as flat as possible. Another thing that it applies to is that nesting of the modules and nesting of functions and snippets of code, the way we do when we write a for loop inside a function and an if statement inside that for function, inside that for loop, and a try except block inside that if. It increases the complexity of the code. If there is a function which has like 20 levels of indentation, it's going to have as many branches as many points of branching in that code base. And again, this will make debugging and writing automated tests virtually impossible, because one piece of code, there would be hidden scenarios and paths and branches in the code base, the routes that when you try to debug, the routes that the code would take for you to follow would just grow up exponentially like the virus, and make our lives very, very difficult. So we should try to keep it as flat as possible. Think of it like quarantining your code. Take snippets out, take reusable snippets, and then the parts that are nested within blocks, take them out as separate functions, and that will just make it easy for us to get confidence over parts of our code. Well, that's how we debug, right? We don't, if we look at a humongous project in first glance, it's daunting, it's scary. And but however, if we break it down into smaller pieces, smaller modules, smaller functions, which we can test and verify and play with at an individual level, then we start getting hang of the abstraction, and it becomes simple. A 5,000 line function, very difficult to debug. 3-line function, 5-line function, easy to understand for everyone. And well, all this talk about complexity also raises another point, which we'll get to in another slide. So readability counts. The code should be readable. This is something that we've been referring to in all of the previous statements as well. Code that we write should be readable, because we ourselves are not able to understand the code that we wrote a few weeks ago. I don't know about you, but I myself can't. I need to go back and read it from scratch as if somebody else wrote it, if I haven't been working on that code for a long time. So it has to be readable. What readability means is that we have to name our things, name our creations properly, and be it variables, functions, modules, whatever we are creating, their names should be self-documenting in a way. And when if it is readable, then we will be able to onboard our team members, and we'll be able to get buy-in from the rest of the team, or future collaborators, much easily, because they would be able to get adapted to the code base just as easily as ourselves. If the code, if it's not readable, then people will just keep giving up, and the amount of effort that will go into trying to get a collaborator, be it within your company or if you're working on an open source project from the community, it will be a daunting task, and the project would die with us, or with our level of interest. Nobody wants to be working on just one problem statement or just one project all their life. Well, if that's your goal, that you want to work on only one piece of that code and you don't want it to grow, so be it. But if you want to grow, you would have to scale. Your creation would grow, and more collaborators would be required to maintain it at different stages. And this particular principle will help us in getting there, and getting collaborators, and nurturing the code base as we go on. Next one says, special cases aren't special enough to break the rules, although practicality beats purity. What this means is that, hey, don't break the rules unless there is a disaster at the doorstep. Many of us had been begging our employers to give us work from home, milta nahi tha. But in the face of disaster, almost every organization is letting, and in fact asking its employees to just stay at home, locked up. Similarly, in our code bases as well, it wouldn't make sense for us to break the rules if we are making rules. Say, for example, one rule, all the test cases should pass before it goes live, before the code gets deployed into production. The code has to be deployed by the pipeline, by the deployment pipeline only, and nobody will enter the server and do things. Well, that is a good rule to have, and we should all follow it. But if the pipeline itself is broken, and then there is the rule which says it should go via the pipeline, and the company is bleeding money, then somebody who is going to say, no, I'm not going to break the rule. We will first fix the deployment pipeline, then we'll fix the code, and then the code will go to production via the route that has been designed for it. Well, the company might not survive such a Puritan approach, and you will be out of your job as well. So following rules is good, but not at the stake, without putting the lives at stake, without putting jobs and the life of the company, life of the project at stake. So we have to understand, we have to recognize where our principles are getting in the way of practicality, and be ready to discard our principles as well, or modify them, or live another day to fight the battle. No shame in doing that. Another example is, for example, in your previous company or in the community, you learned a particular way of writing code, which is the right way of doing it. But let's say uh, you get into another organization and they don't follow that particular convention. It could be like, hey, in the community and in the rest of the Python world writes names things in snake case, which is like a underscore b underscore c is the usual naming convention, but your new employer and the entire code base is using camel case. It wouldn't be prudent at that point in time for you to enforce the rule. Nah, we are going to rewrite and the entire code base now to use snake case everywhere because that's the right way to do it. Nah, it's an impractical way. Impractical. It would be an impractical and unnecessary battle to fight at that point in time. So it just, this particular rule just means try to identify the landscape and then enforce the rules, not just blindly enforce the rules. So it says don't be an andhabhakt. Okay, going next. Errors should never pass silently unless explicitly silenced. So we should make our programs talk to us. The programs should not be giving us silent treatment like some spouses. Uh, we have to make it talk to us, otherwise we won't be able to debug. Applies to both our programs and our relationships. If there is an error, raise it at some level, raise it. Unless, of course, you want to explicitly silence it, and in that particular concern is of no use. It doesn't warrant attention. So another one of my instances was this particular code base had nested try except statements. One try block was nested inside another, which had another one, which was calling another function, which had again another try block, and all of them had except pass, as in none of them were raising whatever the error, just pass. Don't print anything, don't talk about it, do nothing. It became just impossible to walk through that code base. Something used to crash, some output, sometimes the input never resulted in an output, and everyone in the team was baffled why the program is not behaving the way it is supposed to, and it's not even saying why it's not doing that. So we had to go about applying all of the previous principles and this one as well on that code base and refactoring the entire thing. Before we became comfortable with it and were able to move on with the development of that piece. This one says there should be one and preferably only one obvious way to do it. When we are new to something, we need guidance. We need, at that point in time, we just need one designated route to take to get to our goal. For somebody who's trying to, say, for example, like I said, like it says in the second line, a teenager who's trying to get to success, ask somebody who's just given their board exams. They're confused, they're baffled. They want to be successful in life, if you ask them, but which route to take? Should they get into engineering or become or go into medical domain, or what should they do? They have no idea, and they're confused because there are too many routes to success. While we can't solve that, we can attempt to reduce that in the real life, but it's very difficult there. But as far as our code bases go, we can pen it down, we can write documents, we can talk about it, we can make the obvious way the prevalent one, the more talked about one, the more things that people are aware about, people are aware of, and are able to start and move on with things. Of course, after somebody becomes an expert, they're free to explore and seek multiple ways to moksha. But for a beginner, options, or rather options which are of the same stature, and which are not, which are very equal, like, hey, you can. um, Another example, if I may give about this, is for a beginner to start programming for a beginner in Python to write a web application. uh, Django is much easier than Flask, because Flask doesn't dictate which modules to use, which it's got many ways, many modules to achieve the same thing. Whereas Django is saying, hey, here is the proper setup, here is a set of libraries, just get on with it. And however, frameworks will become bottlenecks for you at a later point in time. But when that time comes, you would be quite experienced to be able to solve those problems. If we increase the barrier of entry for everyone, it won't go well. People wouldn't even get into the area in the first place, and we'll quit. So we've got to get them in and then give them the options where they are, when they are wise enough to choose the options. Okay, going to the next one. Now is better than never, although never is often better than right now. It means, well, first one is about punctuality and generic wisdom. Hey, if you've got to do something, do it right. Do it now. It's a good idea to do it now. But jumping on a new idea just because somebody had an epiphany, or the the client, the founder of the company, the marketing team, or whoever is leading you, your efforts in development, or you yourself, for instance, had a crazy new idea, and you jumped on it, you just started writing code without giving it a thought, without thinking it through. There is a very high chance that you will not take it to the end. It's uh, there is a very big chance that it'll die. And I don't know about you, I've got an archive of dead projects in my computer right here, which I started but never finished. Why? Because I jumped on the idea and I started coding right when it popped in my head. So it's good. It's good to mull over things. It's good to ponder and think through the repercussions of our actions, and then start developing. Many times it would happen that, hey, 50 requirements will come on your way, and you can't do work on everything. Many times it would happen that of the 50 things that you're expected to work on, 25 will go away without any repercussion. People, they just become obsolete. So, and they would have in any case become obsolete had you even developed it, had you even solved those problems. Because people who threw those problems at you didn't really think through, they just threw it at you, they didn't. So we need to give problems that some time to evolve before we try to code a solution for them. Okay, moving on to the next point. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Again, this is a corollary of the previous thing which we talked about. We don't want our creations to become our shackles, which inhibit us from moving on to the next thing in our life. Somebody who's written bad code, somebody who's who acted very smart and created a very complicated but smart and awesome, which he believes, or he or she believes is amazing piece of solution, but nobody can understand it because it's too complicated, will eventually find themselves in a position where the company would not let them go. A project they've been working on, they will never be moved on to the next project. Even that particular their creation will become their shackle. They won't be able to move out of that project or from that company for that matter, um, which will not be a good thing. The career growth would stop because you created something that nobody else can take over after you. So it happens everywhere. It happens in projects, it happens in communities as well. So we have to build things that we can hand over to other people, and so that we can move on to the next adventures in our life. Applies to code, applies to life. Next one, and this is the last one. Namespaces are one honking great idea. Let's do more of those. Again, this is all of these things actually summarize what the software engineering course in college had to teach me, which was keep things organized. So one corollary I might give is if the toilet of your house is in the kitchen and the gas stove is in the bathroom, it's not going to be a good experience living in such a house. Same thing applies to the code bases that you're building. Related things should live together. Unrelated things should live in separate, so modules or functions or classes, howsoever you classify the unit. The unit should have only things that are closely related. So high cohesion, low coupling is the motto, is the mantra to success. Well, that's all I have for today, and I'll take questions now.
Thanks a lot, Anuvrat. I think there are plenty of questions. I'll just open them.
Wow. Okay.
Okay. I think most of the questions are for the previous talk. So guys, if you have any questions for Anuvrat, feel free to talk and we shall be able to answer. Any questions, folks?
Well, I guess there aren't any. Let's take from the group, shall we?
The questions are mostly for Uday for the
Right.
previous talk. There is no other questions.
Sure.
So if not, I think probably we can close then. I think thanks a lot, Anuvrat, for a wonderful talk. This was very insightful.
Thanks for having me.
Yep. So folks, if there are no any questions, probably we will close. And before we close, and again, thanks to PyDelhi for collaborating with us, and thanks to EPAM again. I think there is one question. Let's see.
I don't see any question.
Someone raised his hand.
Okay.
I'm not sure who's that.
So there is one question, Sanchit. I can read it through. It's from Sunil.
Yep.
The question is, how do we set standards in Python project, especially on libraries?
I need more information.
Yeah, I think there are a couple of questions now.
Okay. Sunil, it was from, right? Sunil, could you please elaborate a little bit? Are you referring to code that we inherit or code that we are using, which is present in the libraries?
Sunil, I'm going to unmute you. You can also speak if you want. I think it is not letting me unmute him.
Okay.
There is
I'll
one
then
more
try to
question
answer
from.
what I inferred.
There's one more question from
Uh,
Akhil Teja.
let
Would you
me
want to
let me
answer that?
first answer.
Yeah,
Let me first answer what Sunil asked, based on what I
sure.
infer. Uh, so obviously, we can only enforce standards on things that we own. Uh, it wouldn't be wise to teach the whole world how to behave. Uh, let's enforce the standards on our own code base, what we create, what our own uh, team is creating, rather than trying to correct the libraries and everything that we do. So next question.
Okay, so I think Sunil has come back. He's saying Python libraries are used by different developers, but we are trying to return on different machines, trying to rerun on different machines. We are facing reproducible problem.
Reproducibility problems. Okay. For that, you would probably have to isolate things in different environments by probably using different virtual environments, or using Docker to create reproducible environments for every project to run in. Every single, I believe, if you think from the standpoint of a service-oriented or a microservice architecture, is that so?
Okay. Akhil is asking how to resolve cyclic import when creating type hints for the code.
By not doing the cycling imports, which I would need an example to be able to help you better with this.
I think he's trying to implement type hints in the code, and he's trying to ask with whether how do we resolve cyclic imports in case there are type hints available.
In type hints, I'm sorry, I won't be able to help you with that. I haven't got to that yet.
All right. Any further questions, folks? Please send it through.
Let's wait for, like, let's give it 3-4 minutes. If there are more questions, we'll...
Yeah. So meanwhile, Jay has actually sent a quote. I will just read through. It's not a question, just a quote. The real problem is that programmers have spent far too much time worrying about the efficiency in the wrong places and at the wrong timers at the wrong times. Premature optimization is the root of all the evil. That's what Donald Knuth has said. That's a quote.
Donald Knuth, right?
Yep.
Donald Knuth, right. Yeah. Knuth said that. Thanks.
Okay. Vipul is mentioning here is a unique one for Anuvrat. If you like to or have to chance to add a line to Zen of Python, what it will be?
That's an interesting one. Okay.
Yeah.
I guess I would include the thing that I learned in the software engineering class, high cohesion coupling.
Can you repeat what's that?
I said high cohesion low coupling.
Oh, awesome. Yep.
So that's what lies at the heart of trying to organize code in a better way. The related things live together, unrelated things in separate places. So kitchen utensils in the kitchen and bathroom cleaning supplies in the bathroom, and assuming that kitchen and bathroom are two separate modules.
Yep. If there are any further questions, please feel free to post them. I think we can wait for 1 more minute and then we can close.
Sure.
Okay, Leela is asking whether Madhur will be joining or not. So Madhur is not joining. He has faced some technical difficulties connected to his office VPN, so he's not available to take his call. I think that will be all, folks. I think if you have any more questions, probably you can reach out to Anuvrat. I'll share the email ID of Anuvrat, and you can reach out to him. And Anuvrat, would you be able to share the slides publicly?
Yeah, sure. It's actually just a text file.
Sure. I'll share that link with everyone. So again,
Yeah.
thank you all everyone for joining on the Saturday. Okay, be safe, and please do join our next meetup, which is on 7th of April from Pradyun, and it will be a webinar on 7th of April at 9 p.m. All right, then. See you all. Thank you all for joining again. Bye.
Okay. Bye.
Thanks, Anurag.
Thank you. Thanks, HydPy. Thanks, Delhi.
Bye.